Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will start learning about Pipesim network simulation. In Pipesim, we can perform well modeling and network modeling. So in this video, we will concentrate on the network modeling and network simulation. Okay, we will construct crude oil pipeline. Okay, so it will involve first source, click source, and put the source here. You can also see the inputs, either wells, sources, sinks, connections, junctions, equipment, and fluid. Okay, first, the source, of course, and we will involve pump. So you can see here the equipment, choke, check valve, two-phase separator, three-phase separator, generic pump, multi-phase booster, heat exchanger, compressor, expander, and it is for generic equipment, multiplier, injection point, and so on and so forth. All right, we will use generic pump. Click the pump and put it here. And we also need to install the sink. Okay. All right. So it will start from the source and it will end up in the sink. And we need to connect each of this section with flow line. You can see the connections here, either connector, flow line, and riser. And also we can perform nodal analysis for network simulation. Okay, we click the flow line and we connect the flow line from the source to the pump. All right, it has been connected from the source to the pump and also from the output of the pump to the sink. We click flow line and we connect the pump with the sink. All right. Okay, so it has been connected. Now we need to input information inside each of these icons. We start from source. All right, the name source, it is active. And now we need to input the fluid model. As you can see, no global fluids available. So we need to add the fluid system. Click new. Template, none. Okay. All right, so it is a new fluid system that we need to input. Let's say we want to do with black oil simulation. Okay, so it will be easy. Water cut, let's say our water cut is 2.5% with GOR of 500. Standard cubic feet per stock tank barrel. Gas specific gravity 0.64 and water specific gravity 102. Let's say the API gravity is 40 degree of API and no contaminant. Okay. The name BO fluid. It's okay. And then close. All right. The fluid model has been inputted inside the system. Okay. Now we need to define the boundary conditions, either the pressure or the flow rate. Okay. In this case, I want to input the pressure. So the pressure is 1000 psia with the temperature of 500 degrees Fahrenheit. All right, close. Now we need to input information inside the first flow line that connects the source to the pump. We open the flow line. Let's say we call it pump feed. All right. Mode simple. Environment LAN. And for the override global environment data, yes, we check it. Inside diameter 2.981 with wall thickness of 0.322, roughness of 0.0018, no undulation. So let's assume it's purely horizontal with horizontal distance of 124 feet elevation difference 0, right? So it will be horizontal line. Flow line starts at, of course, from the source. Let's say ambient temperature of 45 degrees Fahrenheit. U value type, we select insulated. All right, you can also select bare, coated, user supplied. In this case, we select insulated, okay, with heat transfer coefficient of 0.2 and inside film coefficient include. All right, you can see here the plot elevation versus horizontal distance. So it will be purely horizontal. You can also see the table by clicking this icon. All right, close. Okay, now we input the data inside the pump. The name, let's call it pump. It is active. Okay, use curves. In this case, no. And discharge pressure, it will be calculated. Pressure differential, it will be calculated. Let's say we want to input the power, 120 horsepower. Route, we select Moliere with efficiency of 70%. Okay. You can also input discharge pressure, differential, or pressure ratio. But in this case, we prefer to input the power. Okay. Close. And we continue to input data inside this flow line. Let's call it trunk line. Okay. Simple LAN override with inside diameter of 6.065, wall thickness of 0.28, and roughness of 0.0018 inch, and no undulation, 0 undulation. With horizontal distance, it will be long, 64944. Okay, 0 elevation distance. Flow line starts at, of course, from the pump to the sink. You can also see the plot here and also the table. All right. LAN heat transfer data, again, temperature, ambient temperature, 45, insulated, 0.2, heat transfer coefficient, and include inside film coefficient. All right, so far so good. We can close. And lastly, we input data for the sink. At the sink, we call it sink active. And let's say for the boundary condition, at sink, we set the pressure to be 325 psia at the downstream side. Close. All right, now you can see we are validated. So we can perform simulation, but let's see again, one by one. Source, let's call it source. Fluid system already, and the pressure, okay. The flow line, okay. And the pump. Okay, first, previously we select Moliere, but in this case, let's start from adiabatic. Okay, so make sure you use adiabatic first, and later on we can learn about the Moliere. Okay, let's start from the basic with power, 120 horsepower, 70% for the efficiency. Okay, the trunk line. So far, so good. And of course, the sink. Okay. All right, now we go to network simulation. You can see boundary conditions, required pressure, flow rate, specifications 2, and we have supplied with 2 pressure and flow rate information. Here the boundary conditions. Okay, source, we provide 1 pressure data, which is 1000. Okay, we also provide the temperature, and at sink, we also provide 1 pressure data, 325. That's why the total of the boundary conditions that we have provided is 2. Okay, for the rate constraints, we can leave it blank. Go back to boundary conditions and run. Okay, so the simulation or the calculation has been completed. This is the results, right? Node or branch results. At the pump, sink, and source, the pressure, you can see here, the pressure at the pump. So the liquid has been pumped by the pump. So the pressure increased to this level, 1265.9, the temperature, and this is the flow rate. We can achieve around 12,000 stock tank barrel per day. This is the oil rate, water rate, gas rate. Okay, as per the inputted information, 500 standard cubic feet per stock tank barrel, and water cut 25%. Okay, you can also expand all, right? For the pump, limited by power because we select power, and then the power is 120 horsepower, and this is the pressure at the outlet of the pump, differential pressure, and this is also the differential temperature with pump efficiency of 70%. Okay, the sink and the source. Okay, for display mode, you can select either node or for branch, and we can see also the profile results. First, we can see for the sink, this is the grid, and let's see the show plot. All right, only one point, of course, which is 325 psia. But what about the source? All right, this is the pressure profile. Pressure against the total distance. You can see here, the pressure is increased from 1000 to more than 1200 because of the pump, and then pressure, of course, decreases along the flow line. Down to, of course, 325 at the downstream, at the sink. All right, this is the plot, and you can also see the table by clicking this icon. All right, this is the table, total distance and the pressure. Go back to the plot. All right, very, very interesting. And then we can close. And we can also do this one, PT profile or pressure temperature profiling. We click the source. We click PT profile. Okay, let's do sensitivity analysis here. Branch start from the source, branch end at sink, default profile plot, pressure versus total distance. And let's do sensitivity analysis based on system data, inlet pressure. Let's say we have 3 scenarios, 800, 1000, and 1200. Okay, and for the calculated variable, inlet pressure, 800, outlet pressure, this is important, 400 psia. And we want to calculate the liquid flow rate, of course. All right, so far so good. Now we can run. All right, very, very, very interesting. This is the results for the pressure profile. Again, pressure versus total distance. The blue line is for inlet pressure of 800. The red one is for the 1000, which is our case. And the green one is the scenario with inlet pressure of 1200 psia. Okay, this is the plot. This is the grid. Okay, go back to show plot. You can also click this icon, and you can copy the data and paste on your spreadsheet. Okay, system results. Okay, this is stock tank liquid flow rate at outlet plotted against inlet pressure. Okay, if we increase the inlet pressure, we will obtain higher flow rate at the outlet. Okay, this is the plot and the grid. And this is if you want to see or check the engine console. All right, so far so good. We can recap. So in this case, we have constructed a simple crude oil pipeline system. We use source and of course pump and sink. We also use two flow lines. Okay, first from the source to the pump, and after that the trunk line connecting the pump to the sink. Okay, we have performed network simulation and also PT profiling. Okay, I hope the video is useful. That's all. Thank you so much for watching and see you again in the next Pipesim network videos. Thank you.